Hello everyone, welcome to Tutorials by Decade. My name is Decade, and in this video we are actually going to work on our enemy's ability to move around the map and chase the player. I will forewarn you right now, this will probably be one of my longer videos. We are going to be doing mainly nothing but scripting. So without further ado, let's just get right down to it. So we created in the last video, if you did not follow that video, we created all the animations for the slime, and we jumped ahead a little bit and we created an enemies folder under scripts. And in that enemies folder, we created a base script called base enemy, and then a slime folder with the slime enemy script in it. What we're going to do is we're going to open up the base enemy script, which I already have open. And we are going to start getting our base script for all of our enemies in here. So if you followed my other videos, you know a little bit about inheritance. And what we want in the base enemy script is we want anything and everything that you know all of your enemies are going to have. For instance, an enemy's state, health, a name, how much damage they're going to do, their movement speed, although not all enemies are going to move, it's just easier to put it here. And a whole bunch of other stuff that we can always add or change at a later date. So since this is going to be a script that we're going to inherit from, we're going to try to put everything we need for all of our enemies in here, and we're going to start with the enemy state. So public enum enemy state, and here is where we're going to add whatever states our enemy could possibly be in, which I believe we're only going to need idle, moving, stunned, paused, and attacking. We can always, again, add or change these later. So we're going to do something a little bit different in this script. We're going to start adding headers. We're going to start going over a few things. I don't know if we've done any of this in any of the other scripts, so I will kind of explain as we go along. So the first things first, what a header is it kind of organizes the script in Unity a little bit. So I'll show you what that means once we're done here. But trust me when I say it will help with organization a little bit. So in order to make a header, and you can only do the headers really for your variables. So we're going to do the brackets here. We're going to type in header, and then we are going to put enemy stats. And that creates a header. And of course, within the quotations, you can put whatever you want to help you understand what you're doing here. The next thing we're going to do is we're going to serialize a field. So I don't know if I've ever explained what serialized field means, but in Unity, if you make something public, a variable public, you can actually change it within Unity without having to go into your scripts. But if you make it a private or a protected variable, then it will not show up in Unity. But if you serialize the field, it will. And the reason why we're doing that is because we are going to make a protected string enemy name. Now, this is the first time we've used protected. So public and private, kind of self-explanatory, and we kind of already sort of went over that. But what protected is, it's essentially private, but it could be used on any subscripts. So in other words, whenever we inherit from this script, we'll be able to use this in the other script without having to make it public. You want to try to avoid making things public as much as possible. The only time you really want something public is if another script can, for whatever reason, affect this script. So like public enemy state, we're actually going to make that public just because other scripts, other things could potentially affect the enemy state, such as pausing the game. Otherwise, you would normally want that private where nothing else can affect the script except for the script itself. But we're going to move on with that, and we're going to serialize another field here. And we're going to do protected int max health. And we're going to default that to 1. But again, we'll be able to change that in Unity if you have different enemies that have more health. We're also going to serialize another field, another protected int, and this one's going to be current health. So the reason why we're doing this is because if the character or enemy has more than 1 health, if the sword only does 1 damage, then it would count down your current health until it reaches 0. Yeah, we'll explain that as we go along. And then we're going to serialize field again. We are going to go to protected int damage, and again we're going to default that to 1. We're going to do another serialized field, protected. What did I do there? There we go. Protected float movement speed, and we're going to default that one to 2F. And then we're going to need to create another header. This one's going to be detection, and add some money sign, and aggro or argro, depending on how you pronounce it. I always say aggro or aggro. Apparently, I don't know what I say. Anyway, we're going to move on, and then we're going to do another serialized field, protected float detection range. We're going to default that to 5F. And then serialized field, protected float, aggro range. And we'll change that to 10F at default. And then we're going to do a couple other things. We're going to create a new header for this. We're going to call this miscellaneous. And here we're going to do a serialized field, protected vector 2, initial position. We're just going to do a normal protected bool here. It doesn't need to be serialized. And we're going to do is alive equals true. We are going to serialize this field. And we're going to do protected player. And these two next ones don't need to be serialized. We're going to do a protected rigid body 2D, my rigid body, and protected animator, animator. And then lastly, a public enemy state, current state. So some of these variables should be self-explanatory. Our movement speed is going to be movement. Damage is how much damage the enemy is going to do to the player. Detection range is how close the player has to get before the enemy detects the player. And then the aggro range is how far the player has to go before the enemy stops being aggressive towards them. Initial position is going to be used for enemies that will return to their initial position. So in other words, you can have an enemy that stands perfectly still and doesn't move until the player gets within range and then starts chasing the player. And then once the player gets out of range, the enemy will go back to its initial position. Is alive is a bull that we're going to use a lot later down the road whenever we talk about respawning enemies. So, like with most Zelda-like games, once you go beyond a certain point, enemies could respawn after a certain amount of time. So that's what that's going to be for. The player is going to be a reference to the player. We're going to need that for some of the code that we're going to do. And then obviously rigid body, animator, and current state we've already done for the player. Now, one thing I did not do in the last video is in the in Unity for the slime, I did not add a rigid body. So we're going to need to add a rigid body 2D and make sure it is not affected by gravity. So gravity scale will set to 0, and make sure you put the freeze rotation checked so that way on Z here or Z, and that way the enemy will stay facing the same direction. Once you have that stuff into play, I will show you what I meant earlier. So let's open up the enemy slime or slime enemy script here. Let's go here where it says public class slime enemy mono behavior. We're just going to change that to base enemy. We're going to save the script. We're also going to save the base enemy script, even though there's nothing in it. Now, once we go back to Unity, it's going to compile the scripts here. If we click on our slime and we look at the slime enemy script here, you'll see that enemy stats, that header that we created, and here's all the enemy stats. The detection and aggro, there's the stuff for that, and then the miscellaneous right there. So these are the headers right here. And then everything underneath that we put here is all right here. We're not going to do anything with this just yet because we still have to script a couple things. So let us go back and let's do that. So go back to the base enemy script. All right. So the first thing we're going to do here is protected virtual void start. So again, protected means we can use it in the subclasses. Forget how to explain virtual, but nonetheless, you need to have that in there. And then start, and this turns into essentially like a normal start method. That will be used on every enemy that you attach the base enemy class to. So we're going to do my rigid body equals get component rigid body 2D. We're also going to do animator equals get component animator. This is all stuff that you've done before. This one you have not done before, so initial position is going to equal transform dot position. So what that's going to do is whenever everything starts up, it's going to get the current position of wherever you place the enemy and set it as the initial position. Current health equals max health. So again, whenever you start, the enemy's current health will be its max health. And then we haven't done this yet, but we're going to put a method in here, change. Oh. do that. Change state, enemy state dot idle. And that red squiggly line will go away here in just a moment because we're actually going to do that next. We're going to do a public void change state. We're going to require an enemy state. We're going to call it new state. And then in here, just like with the player script, all we're going to do is current state equals new state. And that's all we're going to do there. And then that'll get rid of that. So now we need to add a protected virtual void update. And in that update, we're going to run this function enemy or switch enemy state, which we have not created yet. We are going to do that right now. And protected virtual void switch enemy state. And again, just like the player, we're going to do a couple switch statements here. First, if the enemy is not alive, then we're just going to return and not do anything. Otherwise, we're going to do a switch statement here. And that switch statement is going to be based on the current state. And case 1 is going to be enemy state dot idle. And if it is idle, then we're going to handle the idle state. Case enemy state dot moving. Handle moving state. Case enemy state dot stunned. Handle stun state, which we're not going to do just yet. We'll get into that a little bit later. Case enemy state paused. Handle paused state. That needs to be a colon, not a semicolon. And lastly, case enemy state attacking. Handle attacking state. And that is all we need to do for this right here. Again, all these little squiggly lines are going to go away in just a few minutes. So let's start creating these states. I'll do that down here. We're going to create in order the idle state. So protected virtual void handle idle state. And if my rigid body dot linear velocity not equals vector2 dot 0. So essentially what that is saying is if your rigid body is moving, then we're going to change state to enemy state dot moving. And if it is not in that state, we are going to do something that we are going to set up here in just a few minutes, but we're going to do check player proximity. That's all we're going to do for the idle state. Now to get rid of that little, first make sure that little squiggly line went away. It did. But to get rid of this one, we are going to create that function right now. So protected virtual void check player proximity. So what we're going to do here is we're going to create a temporary variable. It's going to be a float distance to player, and that is going to equal vector2 dot distance, and the distance is going to be the transform dot position, so the enemy's current position, and then the player dot transform dot position. So essentially it's going to check the distance between the enemy and the player. So that's what that line is saying right there. Now we're going to do an if statement. Distance to player, if it is less than or equal to the detection range, then here we're going to do on player detected, and we'll get to those here in just a minute. Then we're going to do if distance to player is greater than the aggro range and should return to start. Again, we'll go over that here in just a minute. Then we're going to return to start position. So this is just setting up detecting the player and chasing the player, as well as returning to your start position if you were supposed to do that. All right. Again, it might seem a little weird or complicated. I'm going to explain this here in just a few moments, I promise. But first, let's get rid of all those squiggly lines and do a protected virtual void on player detected. And that gets rid of that squiggly line. But in here, all we're going to do is put a comment to be overridden by subclasses. That's all we're going to need to do for this. We're actually going to do the same thing for should return to start. We are going to put in a comment to be overridden by subclasses. And one more time, protected virtual void return to start position. And again, a comment to be overridden by subclasses. Again, we'll go over that in just a little bit. Actually, for this, in order for this to work, we're going to have to return false for right now. Oh, this is supposed to be a bool. That's why. So we can get rid of that. All right. So make sure that this is a bool, and it's going to yell at you if you don't put in something here. So for now, we're going to return false. We can override that in the other classes, so we can get rid of that. There we go. All right. Sorry about that confusion there. So this one needs to be a bool. It should return to start, and you need to have something in here, or else it'll just yell at you the entire time. All right. So that takes care of the idle state as well as everything that should happen if it is not in idle state. So now let's get rid of some of the other stuff. So we are going to handle next, I believe, moving. Yes. So under the handle idle state, we're going to do a protected virtual void handle moving state. And that should get rid of the red squiggly line up there. And in the moving state, we're going to do if my rigid body dot linear velocity equals vector 2, 0. In other words, if the enemy has stopped moving, then we're going to change the state to enemy state dot idle. And then if not, we're going to do else check player proximity again. And that's all we need for moving state. Now for the next 3 states, we don't have anything just yet. So in order to get rid of the errors, though, we need to put them in here. So protected, virtual void, handle stunned state. And we just put a comment in here. Add stunned stuff later. Then again, protected, virtual void, handle paused state. Add paused stuff later. And handle attacking state. And add attacking stuff later. So by doing that, we should get rid of all of our errors up here, which we did. And that should be all that we need to do as far as the states are concerned. Now, there is one more thing that we're going to need to do in order for the enemy to be able to take damage, and that is to have them be able to take damage. So we're going to do public virtual void take damage, and the damage is going to be damage amount. And then if not is alive, in other words, if the enemy is dead, we're just going to return. Otherwise, current health minus equals damage amount. Really, that's all we need to do, but we're going to make sure that if the current health goes to 0 or below, that we do something else. So if current health is less than or equal to 0, then we are going to change current health to 0. This will prevent some issues later down the road. We're going to put a debug log in here, and we're going to say enemy, add a space, add the plus, add the enemy name, add the plus again, quotes, a space, and then has died. And then enemy death function, which we're going to create here in just a second. And that should be all we need for take damage. Now this one is going to be a protected virtual void enemy death. We're going to do is alive equals false. And game object set active false. So for now, this is going to work, but whenever we get to doing respawning and all that, we are going to have to change some of this. But for now, this is the way we're going to do that. If the enemy is dead, then the game object that the enemy is will be just deactivated. Again, that will change. But that should be all that we need to do for the base enemy currently. So now in order to get the slime enemy to work right, we are going to have to go to our slime enemy and do a couple things in here. So first things first, we need to add some variables for just the slime. So we're going to do a header, slime stats. We are going to do a serialized field and private float move time minimum. We'll default that to 1F. And then serialized field, private float move time max. We'll default that to 3F. Then we are going to serialize field, private float stop time min, and we're going to default that to 0.5F. And then we're going to serialize field again, private float stop time, no spaces, time max, and we're going to default that to 1.5F. Then we're going to do a private vector2 move direction. Oh, I forgot a couple things. I'm jumping ahead here. We're going to serialize field, private float move timer, and then serialize field, private float stop timer. And then one more thing we need to do, which is a private float collision timer. And we're going to set that to 0.5F. So the collision timer we're not really going to do anything with just yet. Once we start adding damage and stunned and all that stuff, we will, but I wanted to add that in there for now. So here's where inheritance becomes powerful. So under base enemy, we have all this stuff under start, right? Let me get there. So we have all this stuff under start. So under the slime, instead of typing in all this stuff again, here's what we can do. We can do protected override void start, and base.start is automatically added for you. If it's not, then you just type that in there. And what that means is everything that's in the base, which is this right here, will automatically be pulled into here. And then all we need to do is set random movement. And we're going to create that function right now. So here we're going to do private void set random movement. I guess it would help if I spelled it right up here. So set random movement. There we go. And in here, we're going to do move timer equals random.range. So what a random range does is it picks a random number between two ranges. And it has to be float. It cannot be an integer or anything. So random range move time min. Move time min. There we go. And move time max. And then the stop timer is going to be the same thing, but with the stop time min and stop time max. Then we're going to do float random angle, and then random range between 0f and 360f. Then we're going to change our move direction. So move direction equals new vector 2 math f dot cos random angle I don't know what I was doing there, but math f dot sin random angle. And this one is actually going to be normalized in, oh wait, gotta add that there, dot normalized. And that should be all we need to do there. So what this is doing, math f, what that does is there's a whole bunch of different, as it says right there, math functions. So you do like math f dot whatever it is that you're doing here. So like that cos is cosine, sin is actually sine. So what this is doing is it's taking the random angle, and it's taking the cosine and the sine of that random angle and moving our enemy in that direction. So again, the enemy is going to be random moving around the map. So what's going to happen is the enemy is going to move and then stop for a certain period of time. After the enemy stops, the angle it's moving is going to be changed, and the enemy will move a different direction. And all of that will happen unless the enemy and player get within range of each other, and then the enemy will chase the player, which we'll get into that here in a minute. But we want to make sure we put change state dot, or I'm sorry, parentheses enemy state dot moving, and that's all we need to do for set random movement. So now what we need to do is override some of the states. So we're going to go protected override void handle idle state. It's going to add the base idle state in there, which we want all of that. But we want to do a couple extra things. So if the stop timer is greater than 0, then the stop timer starts counting down. So stop timer minus equals time dot delta time. And then here we'll just do else. And then we'll do set random movement. So all of the functions of the base enemy's idle state. So it's still going to do this right here. So if the enemy stops moving, or it starts moving, it'll change the enemy state to moving. It's still going to check the player proximity, so that's still going to happen. But it's also going to check the stop timer. So if the stop timer is greater than 0, it'll start the countdown. And then we're going to do some functions here after that. So else, in other words, if the stop timer is 0 or less, you set random movement, and then you start moving in a different direction. Speaking of movement, we are going to protected override void handle moving state. And again, it's going to pull in the base moving state. Now, if for whatever reason you don't want the base moving state, in other words, if you want to completely change how the moving state or pretty much anything you override works, all you need to do is just delete the base dot handle moving state. But we don't need to do that. Instead, in here, we're going to do move enemy. If I can spell, apparently my hands and fingers do not want to work right today. So the next thing we're going to do is create the move enemy function. We're going to do that down here. It's going to be private void move enemy. And in here, we're going to do if move timer is greater than 0. Then we're going to do a few different things. First, my rigid body dot linear velocity is going to equal move direction times movement speed. Then we're also going to count down that move timer. So move timer minus equals time dot delta time. We're also going to do the animations. So animator dot set bool is moving to true. Then we're going to do animator dot set float move x to move direction dot x. And then animator dot set float move y to move direction dot y. And then if that move timer gets to 0, we're going to do an else. And we're going to do my rigid body dot linear velocity equals vector2 dot 0. The animator, we're going to set the bool is moving to false. And we're going to change state. Enemy state dot idle. And that is all we need to do for the move enemy. So we have almost everything we need. There is a couple things that we need to do. Remember in base enemy, we did a lot of stuff here that says to be overridden by subclass. So we got to do those now. So first we're going to do protected override void check player proximity. Since there is nothing in base, we can actually get rid of base and do a little bit of checking the player here. So ignore my phone if you heard that. But anyway, we're going to do float distance to player. Did I do this already in? No, I didn't. Not on player detection. Oh, I did this on check player proximity. What am I doing here? Give me a second. I think I screwed myself up here. Oh, I know what we're doing. So we can actually just copy this. So essentially, we are changing the base because we're not going to return to our home location. So we just copy the first half of this. Don't do the distance to player is greater than aggro and should return to start. We don't need that because this player or this enemy is just going to move around the map. That is all they're going to do, and chase the player obviously. So we're going to do that. Now what we're going to do is protected override void on player detected. So again, there's nothing in this one, so we can get rid of the base. And then if current state does not equal enemy state stunned, which we haven't even done yet, so nothing to worry about there. We're going to do move direction equals player dot transform dot position minus transform dot position. Then we're going to normalize that. So essentially what this is saying is we're going to move towards the player. So we're going to get the player's position, we're going to get our position, and the minus means we're moving towards, plus means we're moving away. So if you ever want an enemy that runs away from the player, just change that to a plus. And then we're going to change the state to enemy state moving. That's all we need to do for that. A couple other things that we're going to add in here. We're going to do a private void on trigger enter 2D. We're going to change this to other. So if other dot compare tag player sword, then sword manager is going to be sword, and it's going to equal other dot get component sword manager. If sword not equals null, then we're going to take damage sword dot sword power, which we don't have yet. I gotta add that. So just put that in there. It's gonna give you a little error here, but we're gonna fix that. Don't worry about that. But if the sword is null, meaning the sword's not there, then we're gonna do a debug.log error. No sword manager found. That's just gonna drive me crazy. There we go. And then one more thing that we need to do, well, in this script anyway, is not an if. Why are we doing an if statement? Oh, I'm sorry. We keep that in here. So I am doing an if statement. I'm just got to do it in here. So if other dot compare. I really cannot type today. Compare tag room boundary. Got to be in quotations. Room boundary. Then we're going to change our direction so that way the enemy can't leave the room. So vector 2 direction to center, which is going to equal vector 2 transform dot position negative vector 2 other dot bounds dot center. So essentially, current position to wherever the center of the room is what that is saying. And then we're going to move direction to center dot normalized. And then our move timer is going to be random dot range move time minimum to move time minimum plus move time max minus move time minimum divided by 2. So essentially what all this is saying here is if the player goes to the boundary of the room, or not the player, the enemy goes to the boundary of the room, they are essentially going to turn around, head towards the center of the room for whatever the remaining time was of its initial move. But that's all we need to do in this script. Now, one thing we do need to do is go to our sword manager and add a couple things in here. So the one thing we do need to add is a public int sword power. We're going to change that to 1, or default that to 1, I should say. And that is it, except for under upgrade sword, we can do sword power plus plus, which will add one strength to the sword. And let me just double check my notes here, but I'm pretty sure that is all we need to do. Yeah, that is all we need to do. So make sure we save that. Our slime and base enemies should be good to go. So let's actually shoot over to Unity. Unity's probably going to take a few minutes to compile here. So if we click on our blue slime, we should see all that fun stuff right in here. Enemy name, I'm just going to name it Blue Slime 1. Everything else we shouldn't have to mess with. The one thing that I like to do, just because it drives me crazy, is change that to like 11 and then 5.5. There we go. And the one thing that we have to do is we have to grab our player and drag that over to where it says player. Everything else should be automated. We shouldn't have to change anything. So let's hit play and see what happens. And there we go. There is our slime moving around. Now it's close enough to the player where it's going to start chasing the player and then leaves the player alone. The player can hit it with the sword. Apparently the player cannot hit it with the sword, so that's one thing we got to find out what we did there that we need to fix. So let's go to our sword manager. Sword power is 1. Did we mess something up in the code? The way I've been typing today, it very well could be the case. Slime enemy. Other dot get component sword manager. Oh, that's why. Get component in parent sword manager. So in your slime enemy script in the on trigger enter 2D, make sure we get that get component in parent. One thing, the on trigger 2D could technically go to the base enemy script. As a matter of fact, I think we will do that. Let's just copy this whole entire thing. Actually, Control X. Let's go to base enemy. Down here at the bottom, Control V. But instead of private, we'll do protected virtual. And then let's cut this out here. And then save that. And then slime enemy protected override void on trigger entity 2D. Yeah, we'll do that. And then we'll add this in there. I think that works a little bit better. That way all enemies can get hurt, and if there's an enemy for whatever reason that's going to be immune to the sword, we can override that. So there we go. Now let's see if this worked out. So Unity's going to compile here. Boom, there we go. Player, all right. No reference. That has nothing to do with what we're doing with right now, so cool. All right, so there's the slime. Moves around. And we can kill the slime. The blue slime has died. Now it's saying that room boundary is not defined. So let's go to our rooms. That's because it's not defined. So what we need to do is add a tag. New tag. Room boundary, and then go to the room, untagged. Room boundary, and that should get rid of that error. So let's clear that. Let's hit play again. This is an error somewhere within Unity, but nonetheless, we are good to go. Where did our little slime guy go? There he is. So he'll just randomly move around. He'll stop, stay in one space for a certain amount of time, stop again, and then just change direction. If the player gets close enough, he'll start chasing the player until the player gets out of range, and then he'll go back to his normal logic of just aimlessly wandering around. The player can't get hurt yet, but he can, and there we go. So I know this was one of my longer videos, and I do apologize for that, but there was just a lot to go over, and quite honestly, I wasn't sure where to break up the video. So again, I do apologize. But if you stayed through this entire video and it was helpful and you liked it, make sure you give it the big old thumbs up. Also, don't forget to subscribe, as I do have videos coming out like this all the time. And as always, have a good day, and I'll see you on the next one.